Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have cos A is equals to 2 and we solve this problem for all the values of A. So here first we need to find all the roots of this equation. But you remember one thing is that our A should must be a complex number. It means that we solve this problem for complex values of A. And the very first step we are going to do is first we use here the nice Euler's formula. You know about that. If we have e to the power of iota a plus e to the power of minus iota a divided by 2 is equals to cos of a. We use this nice formula to the left hand side of the above equation. So after applying this formula here, it will be written as e to the power of iota a plus e to the power of minus iota a divided by 2 is equals to 2. So we move this 2 to the right hand side and it will becomes e to the power of iota a plus here we move e to the power of minus iota to the downside, so its exponent becomes positive and these 2 times 2 becomes here 4. So further in the next step we multiply both of the sides by e to the power of iota a on each of these terms, and when we multiply this value by e to the power of iota a, it will be written as e to the power of iota a multiplied by e to the power of iota a plus e to the power of iota a multiplied by 1 over e to the power of iota a is equals to e to the power of iota a multiplied by 4. So in the next step we have e to the power of iota a multiplied by e to the power of iota a is written as e to the power of iota a and its whole square. This and this are gone and we get 1 is equals to, this is 4 times of e to the power of iota a. And now we move the terms from right hand side to the left hand side. It will becomes e to the power of iota a and its whole square minus 4 times of e to the power of iota a plus 1, and this whole equation is equals to 0. And now you see here this this is the exponential equation, and now we convert this exponential equation into the quadratic form. For this we will take here x is equals to e to the power of iota a. So when we put x is equals to e to the power of iota a, so that our above equation is written as x square minus 4x plus 1, and this whole equation is equals to 0. And now further in the next step you see here this equation will becomes in quadratic form. So here we use the quadratic formula to solve this equation. For this first we need to write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 4, and c is equals to 1. And we state the quadratic formula as x is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. This is our quadratic formula, and here we substitute all the values of a, b and c in this formula, and it will becomes the value of b is minus 4 plus minus square root of minus 4 square minus 4 times of a is 1 and c is 1, and it is divided by 2 times of a is also equals to 1. Further we have minus times minus becomes 4 plus minus square root of minus 4 square becomes 16 minus 4 divided by 2 times of 1 equals to 2. And further in the next step we have x is equals to, here we write this term as 4 plus minus square root of 16 minus 4 becomes 2 becomes 12, and it is divided by 2. And further we need more simplifications, and it will becomes 4 plus minus, this is square root of 12, we write it as 4 times 3, and here we break this fraction and we write 2 separately on both of these two values. We have this is 2 times 2 becomes 4, and we get 2 plus minus, we know that the square root of 4 becomes 2, and we get 2 times of square root of 3 divided by 2. These 2 and 2 are gone, and we obtain our x is equals to 2 plus minus square root of 3. So this is the value of x, and now in the next step we need to move backward and we substitute the back value of x. So we take our x is equals to e to the power of iota a is equals to 2 plus minus square root of 3. So further in the next step, here we need to remove this e when we get the value of a. So for this we apply log on both of the sides, and when we apply log this e, and here we use the property of log and we move iota a in the front of this log, and it will becomes iota a times of log e is equals to log of 2 plus minus square root of 3, and we know about that log e becomes here 1. And further, for in order to find all general solutions of this equation, we just write here the term 2 pi 2n pi iota. So we write this term only in order to get all the solutions of the given equation, and here our n should must be belongs to an integer. So further you see here log e is equals to 1, and we move iota to the right hand side, and we get the value of a is equals to 1 over iota times log of 2 plus minus square root of 3 plus, when we divide this iota here, this iota and iota are gone, and we get here 2n pi only. Okay, and now we need more simplifications here, and you know about that 1 over iota is equals to, we rationalize this term and we multiply and divide by iota here, and we get iota multiplied by iota times iota becomes iota square, and we know that iota square equals to minus 1, and we obtain minus iota. It means that 1 over iota is equals to minus iota. So we replace this value here, and we easily get the value of a is equals to minus iota times log 2 plus minus square root of 3 plus 2n pi. This is the final complex solution of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.